Everyone, Mr. Aarons, happy to see you all today, not in person, but soon in person. Next week we'll be getting into those in-person lessons. Today, same old, same old. We are on to lesson 4.3 today, working on some prime factorization and greatest common divisor. Greatest common divisor. All right, so first thing we need to talk about is prime numbers today. A prime number, maybe something you've heard before, are numbers that are the only way to multiply them is to, or the only way to multiply to get them is to multiply them by themselves. For an example of a not prime number, which we'll talk about, has a different word. If you want to sneak ahead, it's actually called a composite. We'll talk about that in a second. A not prime example would be something that has many ways to multiply to get to it. So 24. You can get there by 4 times 6, 3 times 8, 2 times 12, 1 times 24. A lot of ways to get there. That's not prime. Something that is prime only has one way to get there. I don't know any other ways to multiply to get to 23 other than 1 times 23. We're talking integers. Obviously, you could use decimals to get there. But whole numbers, integers, 1 times 23 is the only way to get there. That makes it prime. Other examples, things like we'll talk about some more later, but some other examples would maybe be 7. There's only one way to get to 7. 7 times 1. You can't do 2 times something that's not a decimal to get to 7. So of our integers, it is prime if the only way to get there is multiplying itself by 1. So 24 would not be prime. 23 would be prime. Composite numbers are any number that is not prime. So numbers that have more than one way to multiply them. Examples, 10. You can get there by doing 2 times 5, 10 times 1. There's more than one way. 12. You can get there with 3 times 4, 2 times 6, 1 times 12. There's more than one way to get there. Those are composite numbers. So we either have a composite or a prime. It's one or the other when we're talking about our integers. All right. Oh, also, quick little tidbit right here. This is just a little tip. 1 is considered neither prime or composite. It's kind of just a neutral number that acts as our starting point for these. So right now, we're just going to hop into this real quick. We're just going to decide if these are prime or composite. So I can tell you one thing right now. Any number other than 2 that is an even number is not prime. For example, 4, 8, 6, I did that in a weird order, 10, 12, yada, yada, yada. They're always going to be able to divide them by 2 and get a whole number. Divided by 2 is going to be 2, not prime, not prime, not prime, not prime, not prime, and so on and so on. So any number that's a even number, right away you can be like, oh, well, I can probably divide it by 2. So looking at 26, we can divide that by 2. It's an even number. So one way to get there would be 2 times 13. Another way to get there would be 1 times 26. All we need is 2 ways to get there to know that this is composite. Next, we look at 16. We're going to do the same thing. Divide that by 2. We know 8 times 2 gets to 16. 4 times 4 gets to 16. 1 times 16 gets to 16. Composite. There's more than one way to get there. 13. I know 1 times 13. Anyone else know any other ways to get there? Because I surely don't. That would be a prime number. 13 is prime. 11. I know 1 times 11. I don't know any other ways to get there. Prime number. So we're thinking of different ways to get there. If there's more than one way to get there, it is composite. If there's only one way to get there, and that's by multiplying it by 1, then it is prime. This is going to be a little bit more important. We're going to get into some prime factorization. You've maybe seen these number trees before. We'll talk about those right now. And you'll start to see why this is more important as the lesson goes on and moving into tomorrow even. So we got our prime numbers. We got to get them down to the simplest form to when the only thing that can be multiplied them is 1. And then we'll know they're prime. So for our prime factorization, we're using factor trees, breaking down these composite numbers all the way to prime numbers. So if you see here, on this one, I started with 825. And what I did is I immediately knew it was divisible by 5 because it ended in a 5. So I divided by 5, got 5 times 165. That's what this tree represents. These two numbers multiplied equals the one above it. These two numbers multiplied equal that one, so on and so on. So when we're doing our prime factorizations, you'll see some examples of these, actually quite a few in today's lesson. But basically, you're trying to think of two numbers that can just go into it. There's not necessarily a right answer or a wrong answer as long as they go into it. So for this first one, we had 5 and 165. I like to circle them every time I get to a prime number. It helps me think about it. So I did 5 times 165. I know the only way to multiply to get 5 is 1 times 5. I circle that prime number. Now I go to 165 because I'm done over here. 165. I did 5 again. I knew that 5 could go into it because it ended in a 5. I did 5 and 33. Done right here. Move on to this one. 33 can be multiplied by doing 3 and 11. Those are both prime numbers, and we are done. Just like that. We finished our number tree. Now what we do is we complete our prime factorization by multiplying all of these numbers that we have circled. So take a look at this. If we multiply all those numbers together, 5 times 3 times 11, guess what we're going to get here? 825. These numbers are the prime factorizations, the smallest versions of this number. To complete our prime factorization, I put our tip right here. There's a few steps we have to use. We use exponents. We talked about those last week. We'll show you one right here in a second. And the last step is order them from small to large. So right away, I multiply these. I get 5 times 5 times 3 times 11. Okay. Next, I'm going to put in my exponents. I know 5 times 5 is really the same as 5 squared. That's what we talked about last week. So I rewrote it like this. Did that right down here. And finally, use that final step to order from large to small. So I changed it to 3 comes first, then 5 squared, then 11. From smallest to largest based on the integer. And this right here is our completed prime factorization. I know it took a little bit to get there. We'll get plenty of examples of this. If you need to pause here, get these notes, do that. I'm going to make it so that you can skip around on this. So if you need to come back to this, you can. All right, let's do some number trees and find some prime factorizations here. We got 72. I see it ends in a 2, so I'm going to start by just doing 2 and dividing it by 2. And I get 2 times 36 would be one way to get there. I already have one of my prime numbers here. 2 is a prime number. Only way to get there is 2 times 1. Now I got 36. I want to split that up into, let's do 6 and 6. Nice. Still not prime. Split those up again into 3 times 2, 3 times 2. And right there, we are down to all of our prime numbers. 3 is a prime number. 2 is a prime number. We got them all. Set them up with a little multiplication. I'm going to organize mine and put all my 2's next to each other. So I have 2 times 2 times 2 times 3 times 3. On to my exponent step. I see I have 1, 2, 3 2's. So I'm going to do 2 to the third power times 3 times 3, 3 to the second power. I already put them in my order from smallest being the 2 to the greatest being the 3. So my final form here would be 72 equals 2 times 3, 2 to the third power times 3 to the second power. And I am done. Breaking those down into those prime numbers, solve them from there. Let's do another one. Here we go. 121. I only know one way to get there. 11 times 11. Is 11 a prime number? Well, yes, it is. There we go. Multiply them together. 11 times 11 is the same thing as 11 squared. That is our prime factorization. That one was quick and easy. Done just like that. Okay, so that's kind of your prime factorization using those number trees, breaking that down. Why is this important? I will tell you why right now. Sometimes we need to look for a greatest common factor or a greatest common divisor. This is going to help us simplify our problems. So one way to find those is to use that prime factorization. From there, you pick out all of the parts that they have in common, then multiply. What this is going to do is if I pick out all the parts that these have in common right here, if I picked out all the parts that these have in common, there's nothing. There's nothing that would be in common with them. This is a 2, 3, 2, 2, 3, 11, 11. There are no common divisors between those two. You will see an example like the one I have right here. I did 40 and 60. I'm going to break them down for you quick before we jump into that. I'm doing my number trees to start. When we find our greatest common factor, start with our number trees again. Let's do it. I'm going to go 4 and 10 right here. Break that into 2 and 2. Done right there. Break this into 2 and 5. Done right there. This gives us 2, 1, 2, 3 times to the third times 5. Okay, we got one side done. 60, let's do 6 times 10. Break that down into 2 times 3. Break that down into 2 times 5. These are all prime. Gets us to 2 2's, 2 squared, times 3 times 5. Now, what I'm going to do right here is I'm looking at what they have in common. I wrote them up here already for you, so I kind of just transferred this right here to right there, this right here to right there. So I'm going to toss this away for a second. Now I'm comparing these two, seeing what they have in common. Well, I notice they both have at least 2 2's in them. This one's 2 squared. This one's 2 to the third power, 2 to the second power, 2 to the third power. So they both have at least 2 2's. So look what I did. I took those and I pulled them out. I also noticed that they both have a 5. Those are the common divisors. Pull those out, and how do I find that greatest common divisor? Last step right here, multiply. 2 squared times 5. 2 squared is 4. 2 times 2 times 5 is 20. 20 is our greatest common divisor between 40 and 60. They both can be divided by 20, and that is the largest number that they both can be divided by. The greatest common factors, the greatest common divisors. 20 goes into both of them. I know it took some steps. I know it was a process, but that's how we get our greatest common divisors. The more practice you get with it, the easier it will be. Okay, now it gets a little trickier. We got some letters in there. We got our variables. So they tell us to find the greatest common divisors between these two right here. 6a to the third times b, and 4a to the second times b as well. I already can see that they have some stuff in common. These number trees, I'm going to toss them down here. We're going to move to those. These are a little tricky because with those variables, we can't really do much. We don't know what those are. So what do we do with them? Nothing. We don't do a single thing with them. We leave them just how they are. What's really important is that we find our 6 and our 4. So that's what I'm going to start with. 6 can be written as 3 times 2. Those are prime. 4 can be written as 2 times 2. Those are prime as well. Now when I rewrite, watch what I'm going to do here. I'm going to make this 3 times 2 times, pull this down, a to the third, pull this down, times b. I didn't do anything with those earlier, so I'm just going to bring them straight down. On this side, I got 2 twice, so I'm going to do squared times a squared times b. This one I have to rewrite real quick because I did 3 times 2. If I'm doing this properly, I got to keep them in order from smallest to largest. Okay, those are my finals right here. My prime factorizations. Transfer those over to my other paper real quick. This equals 2 times 3 times a to the third times b. This one equals 2 squared times a squared times b. Now I find what they have in common. I see right here, there's at least 1 2 right here. This one's only 1. This one has 2. So we're going to take one of each of those and pull them out. And we're going to take a 2. What else do they have in common? Well, they both have 2 a's. This has a squared. This one has a to the third power. So I'm going to take 2 of those. Not all of them, but 2 of them because there's only 2 on the bottom. And they both have a b. So I'm going to take that as well. My greatest common divisor. I know it's strange, but there it is. We took out what they had in common, multiplied them together. Greatest common divisor. All right, we got a couple more examples here, and then I'll send you off on your way. I know this lesson's a little bit longer, but it's going to get you through the day. Remember that you can skip around. I'm making it so you can skip around this lesson, move back and forth, go rewatch what you need to. Okay, we got two examples here. Use the prime factorization to find the greatest common divisor of this, and we'll start with that one for now. Okay, 8, I'm going to do 4 times 2. This one's prime. 2, 2, done. So 4 times 2 equals 8, 2 times 2 equals 4. Got 3 primes. This is the same as 2 to the third, or 2 times 2 times 2. This one, we got 20. We're going to go 10 and 2. There's a 2. Right here, we're going to go 2 and 5. We got 2 2's, so 2 squared times 5. Now I'm thinking about what they have in common. The greatest common divisor. They both have 2 2's. This one only has 2, so we're make it 2 squared. 2 squared is the same as 4. That would be our final answer. They don't share that 5 in common. They share the 2 2's in common. Greatest common divisor is going to be 4. All right, one more here. Remember, right now we're thinking about what's important in our number tree is the numbers right here, right here. We don't worry about the variables right now. We'll worry about them later. So we're doing 15, 5 times 3, both prime, just like that. 45, we've got 5 times 9. 9 is 3 times 3, prime, prime, prime. This is 3 times 5. This is 3 squared times 5. What do they have in common? Well, they both have 1 3. So I'm going to pull this out, pull one of those out. 3. They both have a 5 in common. So those match. Multiply those together. 15 is our greatest common divisor. Oh, excuse me. Holy moly. I just about called that early. We got 15 as our number, but we forgot about our m's. So I'm going to line these up. 15m squared and 45m. They both have a 3, we decided, and they both have a 5, we decided, and they both have an m. Oh, sorry. They both have an m, so we're going to add that m on as well because that is also shared. So it's going to be 15m as the greatest common divisor. Don't forget those variables. Go back and rewatch this variable 1 if you need to. Can help you out there. Finding those greatest common divisors, they shared that m in common. They shared the 3 in common, shared the 5 in common. Multiply all those together, we got 15m as the greatest common divisor. All right, that's my lesson for you today. Best of luck. Oh, that's not even the back side. Let me know if you have any questions. Feel free to set up a Google Meet with me. Love to work through some of this with you. Send me an email if you have any questions. All right, have a good rest of your day.